All right, so now let's use our system solving expertise to look at some real world problems. You're going to buy 7 bags of gummy bears and 3 bags of chocolate, and hopefully you'll share. And your total is $22. Your friend's going to buy 3 bags of gummy bears and a bag of chocolate, and she's going to spend $8. So what's the price of a bag of gummy bears and a bag of chocolate? Okay, so let's look at what we've got for what you're going to buy. We're going to use G to represent gummy bears and C to represent chocolate. So you're going to buy 7 bags, and we don't know how much it costs per bag, so we're going to let G represent that, right? So if let's say it's $1 per bag, then you would do 7 times $1. Well, we don't know what the price is, so we're just going to do 7 times G. And then 3 bags of chocolate, and altogether you spend $22. Your friend is going to buy 3 bags of gummy bears and 1 bag of chocolate, and only spends $8. So we have to figure out how much each bag costs. We're going to solve this system. And we can use either substitution or elimination. I'm going to use elimination. So I could turn these 2 terms into positive and negative 21G. But I think something that would be easier would be if this is already a positive 3, I can make this one a negative 3. What would I have to multiply by to make that C term in the second equation a negative 3? Hopefully you said negative 3, because negative 3 times this one will give me a negative 3C right here. So let's write our new equation. Well, actually, we're going to write both of them. I'm going to copy down the one that didn't change, and then we'll write the new one. Oh, no. This would become negative 9G, and then minus 3C equals negative 24. So now that we have our C terms with coefficients that are opposites of each other, we can add these together. 7G and a negative 9G will give us negative 2G. 22 plus negative 24 is negative 2. Divide both by negative 2, and we get that G is 1. Hey, so the gummy bears do cost $1. So that's the price of a bag of gummy bears. But now we need to find the price for a bag of chocolate. So like I said before, pick the equation that's easier. I would pick this one right here before we multiplied through. That's the easiest equation. Plug a 1 in right there. So we'll have 3 times 1 plus 1C equals 8. So that's 4 plus C equals 8. I'm sorry, 3. Oh boy. 3 plus C equals 8 because we're multiplying. And then I have to subtract 3 from both sides, and I get that C equals 5. So the gummy bears cost $1, and the chocolate, or the bag of chocolate, costs $5. And then again, to check, you can always plug 1 in for G and 5 in for C and make sure that it equals 22 here and that it equals 8 here. All right, let's try another one. Now this is the type of problem that you're going to see most often. And in this problem, we've got 2 types of tickets that are being sold, and we've got a total amount of money and a total amount of tickets. So let's read through this problem, and then we're gonna talk about how to set it up. An amusement park sells 2 kinds of tickets. Tickets for children cost $15. Adult tickets cost $40. On a certain day, 2,780 people entered the park. On that same day, the admission fees collected totaled $7,920. How many of each type of ticket did they sell that day? Okay, so when you see these types of questions, you're going to set your system up like this. You're going to have one equation that has to do with the quantity, how many tickets, right? And then you're going to have another equation that has to do with the cost. So let's do our quantity equation first. We don't know how much each ticket costs, right? But we know that we've got two types. We're going to use A for adult and T for, or no, not T, C for children, right? A children's ticket, an adult's ticket, and a children's ticket. Well, child's ticket. A ticket for a child. Just forget I wrote that there. Okay, so let's write an equation for how many tickets were sold that day. We know that the number of adult tickets plus the number of children's tickets came to a grand total of 2,780 because that's how many people entered the park that day. Now let's look at our cost. An adult ticket costs $40. So $40 times the number of adult tickets sold plus $15 times the number of children's tickets will give us a grand total of $7,920. So in these questions, it's all about the setup. Notice that this top equation has to do with the quantity, how many tickets. The total number of adult tickets sold plus the total number of children's tickets sold equals this amount. The second equation has to do with cost. $40 times the total number of adult tickets, 15 times the total number of children's tickets gives us a grand total of $7,920. So now we have to solve it. With these types of situations, the easiest method is usually substitution, so that's what I'm going to use. I'm going to solve this equation for A, so I will get that A equals 2,780 minus C. If you want to solve it for C, have at it. You can do that too. So I'm going to take this, it's, either or. You can either solve for A or solve for C. You'll get the same answer, you'll just get one answer before the other. You'll get them in a different order. All right, so we've got this expression for A, and we're going to plug it in right here. So I'll have 40 times this amount, 2,780 minus C, plus 15C equals 7,920. I'm going to distribute, and I'm not going to pretend to be able to do that in my head. I'm going to use my calculator. So 40 times 2,780 is 111,200. Minus 40C plus 15C equals 7,920. All right, so now we're going to subtract, well, let's combine like terms first. A negative 40 and a positive 15 will give me a negative 25. So I'll have 111,200 minus 25 C equals 7,920. And now we're solving the equation. So subtract 11,200 from both sides. 111,200, I mean. And again, I am going to use my calculator for that. So I'm going to continue up here. I'll have negative 25C equals, let's see what that comes out to be, 7,920 minus 111,200 negative 103,280. And then I'm going to divide that number by 25, well, by negative 25 actually. And I get 4,131. And actually I got a 0.2 in there, but since we're talking about people here, we're going to round down because you can't have 0.2 of a person. So this is the number of children's tickets that we get. And now we're going to plug back into this first equation because this one is the easiest for sure. So I'm going to plug a C right back. You can choose this one if you like, but this one's easier. So I'm going to take this C, plug it in here, and solve for A. So A plus 4,131 equals oh, this doesn't make sense, 2,780. Okay, so we get a negative number for A. 2,780 minus 4,131 equals negative 1,351. Now normally, if this were to happen to you, I would say you must have made a mistake, go back, check, you must have done something wrong. In this case, it's not that I made a mistake, it's that I just made the problem up and didn't make sure that the numbers checked out ahead of time. So this is a correct answer, and this is how you would solve it. There's nothing wrong here. It's just for what we're talking about, number of children and number of adults, it doesn't make sense to have a negative answer. So normally, if you got a negative for something like this, I would say go back and check, make sure you didn't mess up anywhere. In this case, it's just because I made the problem up and I didn't try the numbers out ahead of time. But this is how you would solve it. There's no mistakes here. And I'm sure if there are, then one of you will let me know promptly. All right, we've got one more. All right, so on this one, you're trying to decide on a cell phone plan. Plan A costs $100 per month plus $50 for every 20 gigs of data that you use. Plan B costs $50 per month plus $50 for every 10 gigs of data you use. You know that Plan B is cheaper in the beginning, but it looks like Plan A may be cheaper in the long run. It would depend on how much data you need. How many gigs of data would you have to use per month in order for Plan A to be the better deal? So first, we have to figure out how we're going to represent the gigs of data because we've got different amounts here. So I'm going to propose that just to make them both 20 gigs of data, to make it easy, so we have one variable here for the number of gigs, we're going to say that this is $100 for every 20 gigs. Because that's the same thing as saying $50 for every 10. We've got $100 for every 20. So with Plan A, you've got $100 per month plus $50 per, and we're just going to use G to represent 20 gigs. And then for Plan B, we've got $50 per month plus, so that's cheaper, but then it's 100 for 20 gigs of data. So that's going to be our system. And we want to know when these will be, when Plan A would be cheaper. Because it looks like Plan A is going to be more expensive up front, but then eventually it may become cheaper, right? So we could use substitution here. But really, we've got just one variable. So if we could solve, well, we could also graph these. Let's see, what would make more sense for us to do? We've got, see, this is another case where I made up the problem and it looked really good before I started doing it. So we've got 100 plus 50 every month. And we want to know when that's going to be equal to 50 plus 100 every month. All right, so let's set them equal to each other. Because when we set them equal to each other, then anything beyond that is going to give us a cheaper, more value for plan A. So we've got 100 plus 50G equals 50 plus 100G. So we're going to subtract 50 from both sides. And we'll get 50 plus 50G equals 100G. And then we're going to subtract 50 from both sides. And we're going to get 50 equals 50G. So solving that, we get that G equals 1. And that makes sense. If we look back at our system, if I plug a 1 in here, I get 150. If I plug a 1 in here, I get 150. So G equals 1. But remember that G is equal to 20 gigs of data. So the graph would look something like this. So let's say that this is 50 and this is 100. And this is 20 gigs of data. And this is 40 gigs of data. So if we start at 100 and we go, our slope is 50, so that would mean up 50 over 1. Maybe something like that. And then for the other one, we start at 50, we go up 100 and over 1. So as I go past this 20 gig mark, so from this point on, the one that is lower is going to be the one that's cheaper. Because remember, I'm measuring money, cost on my y-axis. So this one is plan A. Plan A starts out more expensive. But once you get past this 20 gig mark, it's cheaper. It's the better value. Whereas plan B starts off cheap, and then once you hit the 20 gig mark, it's actually more expensive. So when you're making decisions like this, it depends on how many gigs of data you're going to use. If you think you're going to go over 20 gigs of data every month, then you'd be better off with plan A. If you say, no, I never use that many gigs of data in a month, then you'd be better off sticking with plan B. So I wanted to give you a real-world application for this, and cell phone plans are a good one.